My name is Michaela Black. I'm head of school here currently at the School of Computing and Intelligent Systems. The ISRC is particularly exceptional within the university. It's quite state-of-the-art in a number of areas, and the technology that we have, like some of them is worth £4.5–5 million. So at the minute we have the Magee facility, which is very unique and has a lot of contributions that are connected to policy level and health.
I'm Professor of Intelligent Systems. Also, I am the Director for Functional Brain Mapping Facility, which houses magnetoencephalography lab.
I'm Ulster University. I'm a lecturer in computer science at the School of Computing and Intelligent Systems here at Magee. And I'm working on brain-computer interface, on signal processing methods to classify different types of brain responses. It can be event-rated potentials, steady-state visual evoked potentials, brain responses corresponding to imagery, motor imagery for instance.
So what makes the research center unique is that we have the computational neuroscience research, which is a field which can span from fundamental brain sciences to brain disorders and brain-inspired technologies. For instance, we are collaborating with biologists from several institutes to develop computational models across multiple scales to help us understand how, for example, brain chemicals such as serotonin can affect brain activity and behavior, including brain disorders. We have built a mathematical model of the brain where the dots over here are the activities of the brain, and here is a map to something to a higher level. So let's try to put this. For example, here you can see the dots are moving, and you can see activity of the brain are moving in almost real time. And this is captured in a higher level of activity on the right side.
Also, we do what's called neural engineering. So quite often what happens out of these models, some interesting features appear, like some interesting computational features appear that we don't normally have in conventional computing. Like for example, the minute we're looking at how the brain self-repairs. And that's quite interesting to us from the point of view of, can we take that self-repairing paradigm and put it on and use it in conventional computing? And if you look at like modern day electronic systems, one of the holy grail in that is to have electronic systems, these complex systems that can actually repair, particularly when they're operating in remote areas. So if we can change the way that computing is done in conventional electronic systems and put a more brain-like computing system on there, then we could capture this self-repair phenomenon, which would be quite a big step.
This is an example of an FPGA board contains actual chip here, and we look at designing circuits and put them on this special hardware that allows us then to feed in examples like data to some of the brain and the images coming out. On that we can project faults and we can see if the person's certain profile data, what's coming out, what level of repair or in place. This allows us to get a sense of what we see and well it actually perform an example repairs.
I have heavy involvement, which is UK India Education Research Institute project, a BCI operated hand exoskeleton based neuro rehabilitation system for movement restoration paralysis. So basically it's neuro rehabilitation project.
Neurotechnology is a wearable technology that allows people to interact with computers without moving. We have a range of projects going on here in the centre. Some of those are focused on providing alternative communication for the physically impaired. Others are aimed at more blue sky stuff, looking at engineering design and how engineers use their brain when they're designing. We've recently spun out a company called Neuro Rehabilitation that's aimed at developing wearable neurotechnology. It includes hardware, software, and then user applications. So we've developed a unique headset that's embeddable within any standard headgear, including hats and caps and bandanas, whatever. And the idea is that we can provide affordable technology to those who need it most, but also to allow anybody that wants to use neurotechnology to use it as well.
We also have the Robotics Lab, which is doing very unique and high impact research at the minute across diverse areas.
The Robotic Lab is, I think it's like one of the best you can find in the UK for sure, and probably in Europe. So we have a I think it's over 100 square meter electric floor, so that the robots can actually move and charge the batteries while they are moving, which allows you to run experiments for a really long time, because typically the problem with the robots is that the batteries die really quickly.
We've also more recently started doing a lot of work in tactile sensing, so there are a number of people in the centre trying to determine different types of materials using tactile sensors, in particular using the biotech sensor that we have, and it can measure thermal conductivity and vibration and force, and we can use that to distinguish between different types of metals or different types of wood.
The ISRC for me is a real ambassador for not only the school, the faculty and the university. There's three key aspects that acts as a real ambassador for me. It's excellence in research, and as you can see, we've got internationally renowned staff in ISRC. We've got substantial funding coming in at all levels and high impact outputs from all of those research, and that's very, very good at showing both at all levels, both locally, nationally and internationally, of the value that we can add. The second area that it really adds value is that excellence in teaching. We can really improve and add value to the level of teaching, because our students are getting to experience the research, the impacts of research at a very early stage, and continue that right throughout the course. They can come and engage in the centre itself, and it's very engaging and active, and it's got great demos to show, but it also shows the impact and the potential of joining an area of like this, even for industry or research, depending on what way they want to go. The final aspect that I think it acts as a real ambassador is for the university as a civic contribution. We've had lots of visitors at different levels to the ISRC, and we can engage very much and add impact to very local projects. So we can engage with the councils, primary schools and secondary schools around the STEM subject, and try and invigorate and get new STEM ambassadors coming on board for us. But also potentially then for engaging with our service providers in the area, both nationally, internationally and wider fields. So health practitioners, TransLink, security, all of those aspects of a very civic contribution, and that allows us to go out as a university and be part of our community, sell what we're doing and show the value of the work that we're doing, and engage and see how we can add to the local econometric values of our local communities, and that's what we really want to follow a bit more on.